Today we are going to discuss these topics as you can see in the slide: the context model, interaction model, structure model, behavior model, and model driven engineering. Now, what is a system modeling? Actually, system modeling is nothing but actually developing some abstract models of a system, uh, and each of these models represents a different view or perspectives of the system. So you can see you can actually think of a system model to be looking at an abstract any particular the system that is to be developed, the software is to be developed to be seen in an abstract way from different views, from different perspectives. That is what the system modeling is. So system modeling is basically represented with some graphical notations, and those graphical notations are mostly, or you can say always, is done by using a particular kind of notations which are called as the unified modeling language, or we call it UML. So system modeling basically helps the analyst to understand the functionality of the system, that how the system is going to function. Okay, and what are the functionalities, or you can say what are the functionalities that are to be included in the system, and also these are used to communicate with the customers. That is the way the models can be shown to the customers to represent the views, different views, so that we can get the customers feedback or the requirements. Okay, so models can be developed for both existing as well as the system that is to be developed. So for the existing system, when models are created, they are mostly created for requirement engineering process. That is for the purpose of requirement engineering, because the models are basically discussed with the users to get their requirements. That is the requirements that are to be included in the new system that is going to be developed. Okay, so in a way, you can say that is to understand the strengths and weaknesses of the system. So models of the new system are actually used during requirement engineering to explain the proposed requirement to other system stakeholders. That is, different stakeholders, maybe managers, maybe the customers who will be using that system. So to demonstrate them the different functionalities of the system, the model of the proposed systems can be used. Uh, Engineers basically use this model to discuss the design proposals and to document the system for implementation. So for going for the architectural design and all different design parts of the system, these proposed models can be used because models basically represents the views or different views of the system. So um, it is basically helps in the discussing the design proposals and all. Okay, so with different stakeholders, these models of the proposed system can be used. Uh, and model driven engineering process is basically mm, used to generate the complete or partial system implementation from the system models only. So model driven engineering process is a process basically where you create the models so that the entire system or the partial implementation of the system or even the complete implementation of system can be derived from those models, system models. So that is basically uh, a high level, or you can say implementation process using the model. But basically, the most of the in common scenarios, the models are used for the existing system and the proposed system, as the first 2 points indicates here. The existing system of models are for the requirement generation or requirement elicitation, you can say identification of requirements, because those models can be discussed with the users to identify the requirements. Similarly, the models of the proposed systems can be created to discuss with different stakeholders so that design process that can go smoothly from those models. Okay. So different models represent system from different perspectives. There are these perspectives are the external perspectives, where actually the context or environment of the systems can be modeled. Okay, that is the boundary of the systems can be modeled. The environment where the system is to be implemented. Similarly, interaction perspective, where we model actually the interaction between the system and the outside environment, or the interaction within the components of the system, can be shown using the interaction perspective. Similarly, structural perspective is there, where we model the organization of a system or the structure of the data that is processed by the system. So the kind of data that is being processed by the system or the organization of the system is represented using structural perspectives. Similarly, the behavioral perspectives, where actually we model the dynamic behavior of the system. Okay, the way it interacts, or in when it is executing those behavior of the system, the way the behavior of the system is there while executing this, while it is in execution, is shown using the behavioral perspectives. Okay, that is how it represents to the events. So there are different UML diagram types which represents the models. So activity diagram is in actually is used to represent the activities involved in a process or data processing. So different activities which are there, or which we have to use while processing the data, is shown using the activity diagram. Use case diagram is to show the interaction between the system and the environment. So the way the outside environment elements, like some users or maybe some other systems, interact with the current system that is going to be developed, is shown using the use case diagram. Sequence diagram. In sequence diagram, we show the interaction between the actors and the system. Okay, so and between the system components. So the way the different system components interact among themselves, or it interacts with the outside environment, is shown using the sequence diagram. Class diagram actually show the object classes in the system and the association between these classes. So different object classes that are involved in the system is shown using class diagram, and also the way they interact with one another. State diagram is basically used to capture the dynamic environment of the system. That is how the system react to the internal external events is shown using the state diagram. Three ways in which the graphical models are commonly used. Uh, Graphical models, or you can say the UML diagrams, are used mainly for facilitating the discussion about the existing and the proposed system. So uh, those though about the existing and the proposed system for discussion, that is for the discussion purpose, the models can be used. So for this, since these are only used for the discussion purposes, the model need not be completely correct or the complete model. Even the incomplete or incorrect models are also okay for the purpose of discussion. Okay, another way the graphics models can be used is the way of documenting an existing system. This, so when the existing system is documented using models, so models should be an accurate representation of the existing system, but it need not be complete. Okay, so when it is used to represent the existing system. So another way is to have the detailed system description of the system to be generated or implemented. Okay, for implementation, and for this the system should be both accurate and complete, because it is going to represent the system that is going to be implemented. First category of model is the context model. Context model basically represents the used to illustrate the operational context of the system, that is the boundary of the system. Okay, so when we create the context model, we represents what is there in within the system, with what functionalities to be included and what remains outside the system. That is, we set the boundary of the system. So social and organizational concerns may affect these decisions actually, where to position the boundary or where to fix the boundary of the system. So there are also there is the these are basically architectural model uh, that shows the system and its relationship with the other systems. So system model boundaries are basically are to establish uh, what is inside the system and what lies outside the system. So they show basically the other systems that are used to depend on the system being developed. So what other systems are dependent on the on a system that is going to be developed is also shown. The position of the system boundary has profound effect on the system requirement, because when we set the boundaries, we define basically the what requirements are there from the system and what requirements are outside the systems. Means what requirements are not there for the systems. So uh, so identifying the system requirement has profound effect on the setting of the system boundary, because it is the system boundary who determines what facilities to be provided or what services to be provided. So defining the system boundary is also a political judgment, because there may be in the customer organization there may be pressure to set the system boundary in a way that increases or decreases the influence of some departments or some parts of the organization. So that also becomes a political judgment in many cases. So this is one example of the context diagram, that is basically the case study that we have discussed in our one of our previous lecture, where where we have discussed the two different case studies, mental healthcare patient management system. So you can see this is the main this is the boundary that is set. This is the mental healthcare patient management system, the entire system here, and these are the different modules which are connected. Okay, that is patient record management system, so admission system, prescription system, appointment system, uh, statistics system, and the management reporting system. So these are different modules which are to be included in the mental health care management system. So this sets the boundary of the system. Anything other than these modules are outside this boundary. So the context model basically only simply shows the boundary of the system. That is the system and that is the other systems in the environment is shown using the context model, and it doesn't show how the systems being developed is used in the environment. So it only sets the boundary of the system that is going to be developed. Now, mainly the process model reveals how the system being developed is used for broader business processes. So um, we need to have a different kind of model, the process model, which will basically show um, the way the system is used in the broader business processes. And for this, the UML activity diagram is used to show the business process model. Okay, that is to define the business process model. So here comes a diagram of the activity diagram of the process model of involuntary detention of the mental health care patients. Okay, of the case study that we discussed about the mental health care patient management system. So we know that it is the only health problem, health issue, where the patient's consent is not required for detention. Okay. So the doctors can help the detention or can opt for the detention of the patient without the consent of the patient. So here comes the suppose this is the starting point, and this symbol shows the activity. Okay, so first activity of in part of the doctor may be to confirm the detention decision. Okay, so once the detention decision is confirmed, so it informs patients of rights, what are their rights in the detention, and also record the detention decision. Okay, and that comes from the system. That is the you can see these certain records that are being retrieved from the system, mental health care system. Together, it goes on to the decision. If it is a uh, this is a decision symbol where in the activity diagram, where if a patient is dangerous, then the activity is the find a secure place. If the patient is not dangerous, then activity is to admit to hospital. Okay, so if the patient is admitted to the hospital, then admission system has to be taken. Admission has to system has to take care of the admission procedure. Whereas if it is a dangerous patient, then find a secure place. If the place is not available, then transfer to police station. If place is available, then transfer to secure hospital. So in all of these three cases, ultimately it is the detention is carried out either in hospital or in a secure hospital or in a police station. So once this detention is done, then inform the social care, inform next of kin of the patient, and update register of the mental health care patient management system. So, and then it goes to the end of this particular activity diagram. So, this is the activity diagram for the involuntary detention of the patients. There are interaction models. This interaction model is described in these sentences here only. Uh, so in the previous model, we discussed about the context model. Now here in the interaction model, basically we take care of the interaction of the system with the environment, or the interaction among the modules within the system. So modeling and user interaction is important because it helps to identify the requirements, user requirements. Okay, without functionality mapping to the users, the requirement identification is not possible. Okay, so similarly, modeling the system to system interaction basically highlights the communication problem that may arise. Okay, that is module to module interaction within the system. So, oh, sorry, system to system interaction from the particular system to the other system that um, that actually highlights the communication problem. Similarly, modeling component interaction, where actually module to module interaction uh, actually helps us to understand the proposed system architecture structure, uh, how it is going to deliver the required system performance and dependability. So the way the performance of the system will uh, the kind of performance the system is going to give is actually is likely to be achieved, or it can be viewed through the interaction of the components, and that is also an interaction model diagram. So use case diagram and the sequence diagram are the two kinds of diagram that may be used to model the interactions. So first is the use case diagram. So use cases are basically to identify the requirements, or we can say elicitation, requirement elicitation. Okay, uh, and these use cases are part of the UML diagram. So each use case represents a discrete task, and all these uh, these use cases involve actually external interaction. That is the tasks that involve the external interactions. So as I have discussed in the previous slide, that is the use case can be either a user or it can be an external system also. So represented diagrammatically actually to provide the overview of the use case and more detail the textual form. So here is a use case that indicates the transfer of data from the medical reception using by the medical receptionist to the patient record system. So you can see this is medical receptionist is a user, and the patient record system is actually a system, outside system. So transfer of data from the mental health care patient management system to a more general patient record system is what this particular use case is doing. So the tabular description of the transfer of data use case that we have discussed in the earlier form is something like this. Transfer data, the actors are the medical receptionist and the patient record system, PRS. So what this particular use case is doing is the receptionist is likely to transfer data from the mental healthcare patient management system to a general patient record database that is maintained by the health authority. And this remember that this particular patient health record database is outside the system that is going to be developed. That is mental health. It is outside the mental healthcare patient management system. So this is also an entity, outside entity. The information transferred may either be updated personal information of the patients like address, phone number, etc., or the summary of patient's diagnosis and treatment. So those may be detailed informations which are the updated personal information of the patient that may be transferred from the mental health care patient management system to the more general patient record system, or a summary information of the patients can also be transferred. Okay, patient diagnosis and the treatment, summary information of the different diagnosis done to the patient or the treatment that is the patient has received, that can also be transferred, okay, to the more general patient record management system. So what data is going? That is patient's personal information and treatment summary. Either of these. Okay. Stimulus, user command issued by the medical receptionist, because whenever the medical receptionist uh, gives a command, then only this information gets transferred. So response, confirmation that the PRS has been updated. So once the transfer is complete, so there is a response received from the PRS, patient record management system, patient record system, that the updation has been completed. So comments, the receptionist must have appropriate security permission to access the patient information and the PRS. So uh, this is the validation that has to be done. That is the receptionist must have the appropriate security permission to perform this task. So in detail, uh, for the medical receptionist, this is the use case. Okay, that is uh, register the patient is one task that is performed by the medical receptionist in the medical healthcare patient management system, or unregistering the patient can also be done by this is another task. View patient information is another task which the receptionist can do, or transfer transferring of data from the MH, this mental healthcare patient management system, to PRS, the patient record system, more general database, is the transfer data task. And contact patient. So the receptionist can contact the patients over different media, which is also another task. So these are the different tasks that uh, the entity outside entity medical receptionist can do with the medical healthcare patient management system. Okay, so this is the use case diagram. Sequence diagram, as we have discussed earlier, basically used for showing the interactions between the actors or the outside entities with the system or among the modules within the system. So sequence diagram shows the sequence of interactions that take place during a particular use case or use case instances. So this is very important to remember that sequence diagram basically comes from the use case. So for a particular use case, there's an actor and the particular use case of, as we can see here, either this suppose view patient information or the transfer data or this any of these use cases. So for each of these use cases, we can have a sequence diagram. the object and in the sequence diagram, objects and actors uh, are actually listed on the top of the diagram, and there is a dotted line drawn vertically from there, from the objects and the actors. So in the sequence diagram, we have is a list of class objects and actors which are placed sequentially one by one, and there is a line drawn below them uh, to indicate the particular level from where the data flows. So interaction between objects are indicated by some annotated lines, annotated arrows. So here is a sequence diagram that shows the view patient information, use case. So here the use case is view patient information. This one, this is shown. This particular uh, sequence diagram corresponding to this view patient information is shown in this particular diagram. Uh, this is a function of time basically. When you say from here, this side is the at the time through time it varies. This interaction goes on as per with the time. Now here is the record. Okay, this is the record. This is the actor. Sorry, actor. The first actor. This is medical receptionist, and these are the objects, class objects. Three objects. One is the patient info. Another is the medical healthcare database, and the authorization. Okay. So authorization takes the user ID and the passwords or user information of the this one medical receptionist, and if the receptionist is authorized, then it gives the signal back that it is an authorized information. So first, to view the patient information for that particular use case, it has to uh, the medical receptionist has to pass the PID, that is the patient ID. Okay, for which patient ID it wants to view the information. So that will go to the patient class or the patient object here, patient info object. Okay, and there from there the report, that is the detail of that patient information and user ID, will be transferred to the mental healthcare patient management system database. Okay, then this database will contact the authorization module to identify whether this particular receptionist is authorized to view this patient data or not. Then if it is authorized, there this you can see the dash line here which is going back. If it is authorized, then that patient information will be sent back. Okay, and the authorization. Okay, so the patient information will be displayed on the system. If it is unauthorized, the person is not allowed to view the information, then an error message will be shown uh, in the system terminal. So that particular description has been written here. You can read this particular slide, where actually the same whatever I have discussed in the previous slide is written here. Okay, that is the sequence of activities or sequence, that is, you can say, the sequence diagram, uh, the description of the objects and the actors of the sequence diagram, the way sequence diagram works. Okay, for this sequence diagram. Similarly, for transfer data sequence diagram, for the use case which is the transfer data, this use case, this is transfer data and this is the medical decision list. Now transfer data to where? The patient record system, that is the PRS, okay, of the general database, which is outside, which is another outside entity. Now you can see this is the PRS, the to which the data is being transferred. So in between there are the interacting objects are patient info, mental healthcare patient management system database, the authorization. Okay, so for the medical receptionist, it will first send the update info. Okay, so from the patient info, it will send this information to the patient info, the update info, and then patient info object will send the update PRS, that is using the user ID, who is trying to update this transfer or trying to transfer the data, that particular information will be sent to the mental healthcare patient management system. Now mental healthcare patient management system will go through the user ID and it will transfer this entire data user ID to the authorization. Okay, authorization, if it is right, then the patient that will be actually as you can see, the complete line here, that is the full line, it shows the update PID, that is the authorization okay. Okay, that is the authorization okay. And if the authorization is not okay, then it will not allow to update the or transfer the data. This is for detailed information transfer. Similarly, the summary information, the same sequence follows for the summary also. So user ID is verified. If user ID is okay, then update the PID, the summary information. Okay. If it is not okay, then it is not allowed to. It shows the error message, and it is not allowed to update the information. So this above sequence diagram, the previous sequence diagram is described here. Uh, the way this both the sequence works. You can read this slide. That is the same, whatever I described is written here. Then there comes the structural model. Structural model basically displays the organization of the system in terms of components that make up that system and their relationships. So it normally represents the class diagrams. Okay, that is the structure of the uh, classes, the way the classes are being organized. So structural models are normally called as the static models, which shows the structure of the system design. Okay. Or it is also called the it's called as the dynamic model when it shows the organization of the system when it is executing. Okay. So uh, it is mostly used while designing the system architecture. Class diagrams. Uh, Class diagrams are used for developing the object-oriented systems where you create the objects from the classes. Object class actually is nothing but a general definition of the uh, one kind of system objects. So when there are a category of system objects of a similar kind, for those objects can be represented using a class. Class is nothing but a template, you can say, on which the objects can be created. So an association is a link between the classes, uh, where you can when relate the classes from one class related to another through an association that indicates that there are some relationship between these classes. Okay. So when we are designing the models during the early stages of software engineering process, so the objects represent something of the real world, like a person can be an object, a description can be prescription can be an object, a doctor can be an object, etc. So here is a simple example of an association of the email classes. One patient is related to one patient record. So here comes, this is one class patient class. Here is one patient record. Okay, under class, and this is an association between these two classes. That is one patient. One indicates the number. That's the how many patients are related to the other class. So here one means one patient is related to the patient record. So this represents the association between the two classes. So for the uh, association in the mental healthcare patient management system, this particular class diagram may be used. So these are different classes. The lines indicate the association between a class to another class, and the figure here that indicates that one or more. Star indicates that more. More can be any number above one. So one or above or more of this particular class is associated with this class. One or more of this class. So both in one and more means there is a multiple uh, values of this particular class will be related with the multiple values of this particular class. Okay. So that way the entire system's class diagram is shown here in this diagram. Here is an example of a class, that is the consultation class. You can see this one is the consultation class. So the detail of the what is there inside the consultation class is shown here. These are the data elements, the doctors, date, time, clinic, etc. Data, the variables are shown on the first part, and these are the methods which are used for interactions with different classes. So the object of the class interacts through the methods. So second part indicates the methods. The new, prescribe, record notes, transcribe, etc. So what are the key points we have discussed till now in this particular lecture? The a model, system model, is nothing but an abstract view of the system without the details. Okay. Uh, whenever we want to have a particular view of the system, whether it is a structural view, that is the boundary view, we can have a context, you know, model there. Whenever we want to see the interaction between the models, between the modules of the system, we can go for an interaction model. Okay. Uh, then in between them, we can also have an activity diagram to show the way the process model works there, and we can also have the class diagram to have the process model view. So, or we can have the structural model, as you can see here on the class diagram. So we can have all these different kind of context, interaction, structure, behavior, and different views. All these different views can be achieved through the model, system models. Context models show how the systems that is being modeled is positioned in an environment with the other systems and processor. So that is what the context model indicates. It shows that the way the system is placed with respect to the entire environment and the other systems around with which it interacts. So use case diagram and sequence diagram are used to describe the interaction between the users and the systems in the system being designed. So as we can see, the use case is basically the way interaction is done with the external elements. So we using the use case, we get the requirements of the system. Okay. Similarly, interaction model is used for showing the interactions between the actors and the objects. So from each of the use case, we can derive an interaction model, or a sequence diagram can be drawn, okay, which it actually represents the interaction model. The structural model is comes from the class diagram. So it indicates the organization or architecture of the system. So class diagram is used to define the static structure of the classes in a system and their association. Okay, thank you.